Hey guys, Mr. Backerberg here. In this video, we're going to look at continuously compounded interest. So suppose that you have P dollars and you're investing it at a fixed annual interest rate, R, which we're going to express as a decimal. If interest is added to the account N times per year, then the amount of money present after T years can be written as A of T, so the amount of money in your account after T years is equal to that P value that you started with times 1 plus R over N to the power NT. Now, as far as that N value goes, if you were compounding monthly, then you would have an N value of 12. If you were compounding weekly, you would have an N value of 52, or daily, it would be 365, or you could keep going. You could go by the hour, or by the minute, or by the second. But instead of the interest being added at discrete intervals, if we added it continuously at a rate that's proportional to the amount of money in the account, then we can model the growth of the account using an initial value problem. So we could use the differential equation dA dt is equal to R times A, using the initial condition that A of 0 equals that P value amount. Then what we could do is use limits to show that P times 1 plus R over N to the power of NT, as N is approaching infinity, is really equal to P times E raised to the power of RT. So that's where we get the continuously compounded interest formula from, where it says A of T equals P times E raised to the RT power. So we say that interest paid according to this formula is being compounded continuously, and that R value rate we call the continuous interest rate. So let's suppose that we deposit $800 into an account that pays us 6.3% annual interest, and we want to figure out how much money we're going to have after 8 years if the interest is paid. First, we're going to do compounded quarterly. So we're going to look at A of 8, since we're looking at 8 years. So this would be that principal initial investment. So that $800 times 1 plus the R value we want to take and turn into a decimal. So 0.063 over N is the number of compoundings. If we're doing this quarterly, that means 4 compoundings per year. And then our power is that N value of 4 times the number of years, 8. So if we were to take all of this and type that into our calculator, then after those 8 years, we should have $1,319.07 if we round that off. Now, if we switch that up and instead look at this compounded continuously, everything else is exactly the same. $800, 6.3% interest for 8 years, but we're doing this one continuously. So now if we use our continuously compounded formula and look at A of 8, then that's going to be our 800 times E raised to the power of the rate, so 0.063 times the number of years, 8. So now if we type that right-hand side into our calculator, we're going to get $1,324.26 if we round that off. So the more times that you compound per year, you're going to get more money. But the limit, the most that you could get is kind of this compounded continuously. So the maximum you would get is this $1,324.26. That's going to be it for this video. Thanks for watching.